So now we are moving on to our third problem regarding Newton-Raphson load flow analysis. So what I am going to do is, I have here in this problem, unlike these other two problems, what I have given is, I have given a constraint for reactive power. Okay, so as usual we will be doing with our problem. So what will be our step 1? Step 1 is Y bus formulation. Step 2 is we are filling out the bus data and we have to find out what all parameters we have to take, and then we will find out delta P and delta Q. For PQ we have to find out delta P, delta Q, and for PV buses we only have to find out delta P. Then we are going to find out J matrix. Then we are going to find out J inverse into delta P, delta Q, and we will get that value as delta delta and delta E value. Then we will find out our delta for next iteration is equal to present value plus delta delta K. Similarly, Vk plus 1 value magnitude will be Vk plus delta Vk plus 1 value, and the value for delta P for the consecutive 2 iterations is less than the eligible rate or epsilon value, or usually we take it as 10 raised to minus 3. Then we will stop our iterations. Okay, so for my table I have to find out step 1, I have to find out my Y bus. So for finding out Y bus, we can check here what will happen. Here the given data is in impedance form, isn't it, plus J form. So we have to find out the corresponding admittance for the value. So I have to find out the corresponding admittance. So what I will do for my easiness, 1 to 2 is there, 1 to 3 is there, and 2 to 3 is there. 1 to 2 the value is 0.12 plus J 0.83, and 1 to 3 it is 0.65 plus J 0.78, and 2 to 3 it is 0.19 plus J 0.56. So I am going to find out the inverse of it. That is, my calculator should be on complex mode and it should be in radians. So the value is 0.12 plus 0.83 I inverse value. That value will be 0.1706. 0.1706 plus 0.1706 and minus 1.180 J 1.180. Okay, and next what I have to find out is 0.65 plus 0.78 I inverse. I got the value as 0.6305 shift minus J 0.7566, and the next value I have to find out is 0.19 plus 0.56 I, and that value inverse will be 0.5433, and the value will be minus J 1.6014. So this is the value I am getting for my, so this I can notate it as my Y12, this is my Y13, and this is my Y23. Now we have to find out our Y bus. So how will we find out? This is a 3 bus system. So my Y bus will be absolutely Y11, Y12, Y13, Y21, Y22, Y23, Y31, Y32, Y33. So this will be my Y bus matrix, and my Y11 value will be equal to all that connected to my Y first bus. So Y12 plus Y13, that value I have to sum up and I will get, and Y12 value will be equal to Y21 value, that will be equal to minus of Y12 value, that is equal to minus 0.1706 plus J 1.190, and my y13 value will be equal to y31 is equal to minus of y13, that is equal to minus 0.6305 minus plus j 0.7566. Similarly, for y21 it is there. Then for y22 value, what I have to take is y22 is all those connected to my second bus. So y12 plus y23 value, that I have to find out, and y23 will be minus that will be equal to y32, that will be equal to minus of y23, that value will be equal to minus 0.5433 plus j 1.6014 value. Then y22, y23, then y31 value is there, y32 value is there, y33 value will be all those values connected to my bus 3. So the value will be here. I have to find out. So what I will do, I have to find out and I will come. I have calculated my y bus. So y11 is minus 0.8011, y12 value it is here, y13 value, then y21 value same value, then y22 value will be 0.7139, and y23 value will be written, then 31, 32 and 33 value. So I have completed my y bus. Now what we have to convert, we have to convert it into our radian mode, I mean in the polar form. So what I should do is I have to calculate my value to r theta. So I will get 2.095 angle minus 1.178. So I can write it as 2.095 angle minus 1.178. So what is it? 2.095 7 I am taking. So similarly I am converting all the rest. So I have converted this y bus in my polar form, and you can see our polar form data like this. So next step what we have to find out is step 2. We have to write all the bus details, okay, or bus details I have to write out. So I am going to write it. So here I have written all the bus details. So what is bus 1? Bus 1, the value is given as 1.05 angle 0 and no other value is given. So this is our slack bus or reference bus. No other value is given. For bus 2, what they have given is they have given load values, isn't it? So that is 450 and 200 MVAR. So I am converting it into per unit. I will take base as 100. So 4.5 and 2 will be my values. No voltage value is given. So this is definitely a PQ bus. And for bus 3, what they have given E3 value is 1.04 and 500 megawatt. PG is 500. So this is 5 per unit if I am taking it as. But they have given the Q limit. So 10 less than Q3 less than or equal to 100. So this they have given the Q limit, okay. Since P and V value, now I take this bus as PV bus, but the condition will change if, since a value of Q limit is given, we have to find out Q also. Otherwise we don't have to find out the Q value. If the bus is a PV bus, we don't have to find out delta Q value or QI calculated. But since the Q limit is given, we have to check whether this bus obeys the value within the Q limit. If this constraint is violated, then we can treat this bus only as a PQ bus. That you will understand in our following session. So now what we are going to do is we have completed our step 2. So we are going to find out our step 3. Okay. So what I have done is I have rewritten all the values Y bus data in polar form, that is in radian mode, and bus data I have taken. So again I am reminding you, this bus is a PQ bus because PLQL is only given, and this bus is PG is given, voltage is given, so it is a PV bus, but the constraint of reactive power is given. So we have to calculate this Q, and only if the Q constraint is satisfied only we can take it as PV bus, else it should be converted into a PQ bus. Now we have to move on to my step 3. So for step 3 I have to calculate for delta P and delta Q values. For bus I is equal to 1, we don't have to do anything because it is a slack bus, and for bus I is equal to 2, that is a PQ bus. So what we have to do, we have to find out delta P2 and delta Q2. So how will I find out delta P2? Delta P2 is equal to P2 scheduled minus P2 calculated value, that is equal to P2G minus P2L minus P2 calculated. So what is the equation for P2 calculated? P2 calculated will be equal to sigma. If it is Pi calculated, then sigma n is equal to 1 to total number of buses Vi y in Vn cos theta in plus delta n minus delta I. This is our general equation for Pi calculated. So I am writing my P2 calculated. P2 calculated value will be sigma n is equal to 1 to 3 V2 y2n Vn cos theta 2n plus delta n minus delta 2 value. So I am rewriting it neatly because we want this value again. So V2 y2n, that is y21 V1 V2 y21 V1 cos of theta 21 plus delta 1 minus delta 2 plus V2 square, V2 into V2, V2 square y22 into cos theta 22, because delta 2 minus delta 2 will be 0, plus V2 into y23 V3 cos theta 23 plus delta 3 minus delta 2. This will be our equation, and we have to substitute the values to find out the P2 calculated. So what is the value of V2? For value of V2, this is a PQ bus, so we will take it a V2 value will be, here we will take V2 value is 1 plus J0 or 1 angle 0. So 1 into, what is Y21? Y21 value will be equal to, Y21 is 1.1923 into V1 value is 1.05 cos of theta 21 value will be 1.7413 plus what is V2 square value? V2 square value is 1, and Y22 value will be 2.8716 into cos of theta 22, that is 1.3196 plus V2 value is 1, Y23 value is 1.691, Y23 V3 value it is given as 1.04 into cos of, what is theta 23 value? Theta 23 value is 1.8979. So this value we have to find it out, and we have to find out our calculation. I am doing the calculation. So it is 1.193 into 1.193 into 1.05 into cos 7.7413 plus 2.8716 into cos of minus 1.3196 I'm closing, plus 1.691 into 1.04 into cos of 1.8979. So my value will be equal to minus 0.06 minus 0.0632 will be my value. Okay, so my value will be minus 0.0638. Next we have to calculate our Q2 value. This is delta P. So P2 calculated we have found out. So delta P2 value will be P2 generated, that is 0 minus P2 load, that is 4.5 minus this thing. What is it P2 calculated is? So it will be 0.0638 per unit. So the value will be minus 4.5 plus 0.0638, which is not on, sorry, minus 4.5 plus 0.0638, that value will be equal to minus 4.4362, that is equal to minus 4.4362 is my delta P2 value. Okay, next what I have to find out is I have to calculate my delta Q2. For delta Q2 is equal to Q2 generated minus Q2 load minus Q2 calculated. Here it is very difficult to find out Q2 calculated, so I am finding it out. Q2 calculated. Qi calculated is equal to minus of sigma n is equal to 1 to n Vi Vn sin theta In plus delta n minus delta I. This is our equation for Qi calculated. So I am going to find out Q2, that is equal to minus sigma n is equal to 1 2 3 V2 Y2n Vn sin theta 2n plus delta n minus delta 2. This I am writing it clearly because we want this equation again. So V2 Y21 V1 sin theta 21 plus delta 1 minus delta 2 plus V2 into V2, it will become V2 square Y22 into sin theta 22, because delta 2 minus delta 2 it will be 0, plus V2 into Y23 V3 sin theta 23 plus delta 3 minus delta 2. So this will be our equation, and I am finding out my value by substituting it. V2 value is 0. V2 value is 1, and what will be Y21? Y21 value is 1.1923 into V1 is 1.05 into sin theta 21. Theta 21 value is 1.7413 plus V2 square value is 1. Then Y22 value, it will be 2.8716. 2.87, here it is given 2.8716 into sin theta 22, that is minus 1.3196 plus V2 1. Y23 value is 1.691 into that value V3 value is 1.04 into sin of 1.8979 value. I have to calculate it, and finally I have to give a negative and I will get my value. So I am calculating it, that is 1.1923 into 1.05 into sin of 1.7413, closing the bracket, plus 2.8716 into sin of minus 1.3196 plus 1.691 into 1.04 into sin of 1.8979. That value I will get it as 0.1176. So that is 0.11767. Okay, so 0.117, or I can write it as 0.1177. That is per unit, and this minus value I have to put it. So Q2 calculated will be equal to minus 0.1177 1176. So my delta Q2 value is equal to Q2 generated, no value is there, minus Q2 load is 2 minus this value. So what I will get is minus 1.8823. So it is minus 1.8823 per unit is my delta Q2 value. Next what I have to find out is I have to find out for my bus 3. So what will be for my bus 3? For my bus 3 it will be I is equal to 3, that is a PV bus it is given. So we have to find out only delta P3, but Q constraint is given, so we have to calculate the Q also. So first I am calculating delta P3 is equal to P3 scheduled minus P3 calculated, that is equal to P3 generated minus P3 load minus P3 calculated. So already what we have done, we have that P3 calculated value. P3 calculated is equal to sigma I is equal to 123 V3 Y 3n Vn cos of theta 3n plus delta n minus delta 3. This we need again, so I am rewriting it neatly so that the value will be V3 Y31 V1 cos of theta 31 plus delta 1 minus delta 3 plus V3 Y32 V2 into cos of theta 32 plus delta 2 minus delta 3 plus V3 square Y33 into cos of theta 33. So this is the value for P3 calculated, and we are substituting it as V3 value, it is 1.04. Since V3 is here everywhere, I can write it as V3 1.04 into common, like that I can do, or I can do 1.04 into Y31 value is 0.9848 into V1 value is 1.05 into cos of theta 31 is 2.2655 plus V3 value is 1.04 into Y32 value is 1.691 into V2 value is 1, so no need of writing, is cos 32 value is 1.8979 plus V3 square value it is 1.04 square into what is Y33 is 2.9292 into cos theta 33, that is cos of minus 0.9356. You do it in the calculator and you will get the value. So the value I got is just 0.063. Then I have to calculate my delta P3. Delta P3 value is P3 generated is 5 minus load, it is not there, minus then 0.6263. So 5 minus answer I will get it as, that is equal to 4.37366 per unit. So this is my delta P3 value. Delta P3 value I got it as delta P3 value is around 4.33 some value I am getting it. Then again what I have to find out is, here it is a PV bus but still Q constraint is given, so we have to find out QI calculated. That QI calculated equation we already know, so I am just finding out Q3 calculated. Q3 calculated is sigma I is equal to 123 minus of V3 Y3n Vn and sine of theta 3n plus delta n minus delta 3. This is our equation. So that is equal to minus of V3 Y31 V1 sine of theta 31 plus delta 1 minus delta 3 plus V3 Y32 V2 cos of theta 32 plus theta 32 plus delta 2 minus delta 3 plus V3 square Y33 into sine of, it is sine only, okay, sine of theta 3. This is our equation and we are substituting our value. So what is V3? V3 value we know it is 1.04. So minus of 1.04 into y31 value is 0.9848 into 1.05 into sine of 2.2655 plus V3 is 1.04 into 1.691 into V2 value I don't know, cos, no it is not cos, it is sine of 1.8979 plus 1.04 the whole square into y33 value is 2.9292 into sine of minus 0.9356. This value I have to find out. So what I will go, it is 1.04 into 0.098 into 1.05. Here I will take it as sine of 2.2655 plus 1.04 into 1.691. Here it is again sine of 1.8979 into 1.0 square 2.92. Here it is again sine. So my value will be equal to minus 0.05. So that is 0.0587 is my value. P3 calculated, that is 0.0587. So what was my constraint? Given constraint was 0.1 less than or equal to Q3 less than or equal to 1 per unit was our constraint, but this Q3 calculated value is less than Q minimum limit given, so the Q limit is violated and we should consider this bus as a PQ bus. Okay, so bus 3 is a PQ bus, so we can say this bus is again treated as a PQ bus. So in order to find a PQ bus, delta Q3 also should be calculated, that is Q3 scheduled minus Q3 calculated. Q3 scheduled, nothing was scheduled as it was a bus, so 0 minus this 0.587 0.0587. So delta Q3 value is equal to minus 0.0587 per unit values. That will be our delta Q3 value. So we have found out our first 3 steps and now we have to find out what is our J matrix. Okay, so there is a little problem. Q3 limit is less than Q minimum, then I have to take this limit is 0.1. okay, sorry, so what I have to take is 0.1 minus this value. Okay, so what I have to do is plus 0.1, so 0.041 is a value. Okay, so I am rewriting it. If I am changing, if my Q3 calculated value is less than, then Q3 calculated will be equal to Q minimum. So my Q minimum is 0.1. Then Q3 calculated, it is not there. Q3 scheduled, I am taking it as 0.1. So my Q3 scheduled is 0.1 minus 0.0587. so that will be equal to 0.1. that is equal to 0.0413 per unit. So the delta Q3 value is 0.0413 per unit. That value we have to take it. Okay, so I am stopping it now. Now next I will show in next video. Okay, so next we are going to find out our J matrix, then we will find out J inverse, then we will multiply it with this delta P delta Q values, and then we will get corresponding parameters of voltage, that is V and delta, and we find it out for our next iteration. Okay.